This is the thermal experiment for the ME421 Equivalent Systems Lab. So what we have here is a hot plate, a flask with 15 grams of water, and an RTD, a resistive thermometer device that is it's basically a resistor that changes resistance based on temperature. So what we're going to do is we're going to set the hot plate to 50 degrees Celsius. We're going to measure out 15 grams of water. We're going to put the water on the flask and then measure the temperature. So we have LabVIEW connected to the multimeter, which is going to read the temperature in and plot the graph, or plot the temperature versus time. So first thing we need to do is measure out 15 grams of water. In order to accurately measure the 15 grams of water that we're going to need, we're just going to use a simple scale and some water here. So I'm going to go ahead and put the flask on the scale. Zero that reading. And there's going to be a little drift, but hopefully it should be fine. So then I'm just going to add water until we get up to 15 grams. So now we have 15 grams of water and we can start the experiment. Now that we have our 15 grams of water measured out, we're going to go ahead and set the hot plate to 50 degrees Celsius. And wait for that to reach temperature. Okay, now that that's at temperature, we're basically just going to put the water. I've got this already set so that the RTD is in the right location. So I'm going to put the water right on the hot plate and run my VI. And so this is going to record the temperature versus time. This data will be shown, or it will be provided in Canvas. A couple things about the VI screen. So we've got enable offset compensation, which is setting the multimeter just to compensate for temperature changes in the air. And then there's replace dropout, so if there was a bad measurement, if it read 0 ohms, for example, or the computer tried to get a measurement from the multimeter before the multimeter was ready, it would show up as a 0, so it just gets rid of that and uses the last data point. So as this warms up, eventually it will reach steady state, which should, in theory, be the steady state temperature of the hot plate. And so we can calculate tau based off of the 63.2% method.